Okay, so good evening, everyone. This is the 11th live session of Geotechnical Engineering 1, and today's topic of discussion will be consolidation of soils. As usual, this discussion has some MCQ, true false questions, and some numericals. So you take out your copy, pen, and calculator. I'll first dictate all the questions. I'll give you some time, around 15 minutes, to solve the questions, and then I'll start discussing the answers. Okay, so I'll start now. The recording is started. Yes. I am clearly audible, right? Hello?
Yes, sir.
Yeah, okay. Okay, start writing the questions first. The first question is, in partially saturated soils, the initial consolidation is due to. In partially saturated soils, the initial consolidation is due to. The options are squeezing out of water from the voids. Option 2, expulsion and compression of air in the voids. Option 3, expulsion of highly viscous water. And option 4, none of these. In partially saturated soil, the initial consolidation is due to squeezing out of water in the void, expulsion and compression of air in the void, expulsion of highly viscous water, or none of these. Next question. Also, consolidation of soils is due to load, which is static and short term, dynamic and short term, static and long term, dynamic and long term. I repeat the question. Consolidation of soils is due to load, which is static and short term, dynamic and short term, static and long term, dynamic and long term. Okay, next question. Secondary consolidation is mainly due to the expulsion of highly viscous water, plastic readjustment of solid particles, both of the above, or none of these. Shakir, if you have missed the first two questions, don't worry. You just write it down when I discuss the answers, okay?
Is this third question?
This is the third question, yes.
Okay.
First two questions you write it down when I discuss the answers, okay? So this question is, secondary consolidation is mainly due to the expulsion of highly viscous water, plastic readjustment of solid particles, both of the above, or none of these. Next question. Time is an important factor in the consolidation of clays because of low value of permeability. Time is an important factor in the consolidation of clays because of low value of permeability. You have to state is this statement is true or false. Okay, and one more thing, if you are finished writing this question, just tell me. I have to tell something. Done with the question?
Yes, yes.
Yes, today's topic is consolidation of soils, and the topic of the next live session is settlement of compressible layers. So, since both the topics are included in one chapter only, consolidation of soils, I have not given any questions of settlement in this discussion. Okay, I have given you problems purely based on the concept of consolidation. Okay, and the application of consolidation for settlement of the soil layers, I will be incorporating that in the next class. Okay, clear?
Yes, yes.
Yeah.
Yes.
Okay, next question. Which of the following is not an assumption in Tarzagi's theory of one dimensional consolidation? Soil mass is homogeneous and isotropic. Soil is fully saturated. Darcy's law is valid. Drainage of water occurs in both horizontal and vertical directions. I repeat the question, which of the following is not an assumption in Tarzagi's theory of one dimensional consolidation? The options are soil mass is homogeneous and isotropic, soil is fully saturated, Darcy's law is valid, drainage of water occurs in both horizontal and vertical directions. Which of the following is not an assumption in Tarzagi's theory of one dimensional consolidation? Next question. Coefficient of consolidation depends upon coefficient of consolidation depends upon permeability, coefficient of volume change, unit weight of water, or all of these. Coefficient of consolidation coefficient of consolidation depends upon permeability, coefficient of volume change, unit weight of water, or all of these. Next question. An undisturbed sample of clay 24 mm thick consolidated 50% in 20 minutes when tested in the laboratory with drainage allowed at top and bottom. The clay layer from which the sample was obtained is 4 meter thick in the field. How much time will it take to consolidate 50% with double drainage? This is the first part. The second part is, if the clay stratum that is in the field, the clay stratum in the field has only single drainage, calculate the time to consolidate 50%. Is the question clear? Hello, is the question clear? Do you have any doubt?
Yes.
Tell me when you have finished writing the question. Done?
Yes.
Just a moment. I'll just check whether this recording is going on. I don't think my PPT is visible, but it's not showing over here. What is happening? Okay. Next question. A soil sample which has been subjected to consolidation test has an area of 50 centimeters square. Dry weight of sample is 190.24 gram. Initial height of sample is 25 millimeter. Taking G as 2.67, determine the height of the solids and the initial void ratio of the soil. Just a moment, I just stop presenting and start presenting again. See if there is any glitch. Just a moment. Yeah, okay. A soil sample which has been subjected to consolidation test has an area of 50 centimeters square. Dry weight of sample is 190.24 gram. Initial height of sample is 25 millimeter. Taking G as 2.67, determine the height of the solids and the initial void ratio of the soil. Done?
1 minute, sir.
Okay. I believe you have done now.
Yes, sir.
Next question. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeter square per second. Assuming double drainage, how long will it take to attain half the ultimate settlement under the load of structure? The question is not about settlement, it is about the time of consolidation. Okay. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeter square per second. Assuming double drainage, how long will it take to attain half the ultimate settlement under the load of the structure? Done?
Done, sir.
Okay. Why it is not showing over here? Okay. Next question. Two clay specimens A and B of thickness 2 centimeter and 3 centimeter have equilibrium void ratio 0.68 and 0.72 respectively under a pressure of 200 kN per meter square. If the equilibrium void ratio of the two solids are zero point 0.5 and 0.62 respectively, on increment of pressure to 400 kN per meter square, find the ratio of the coefficients of permeability of the two specimens. The time required by specimen A to reach 40% degree of consolidation is one fourth of that required by specimen B for reaching 40% degree of consolidation. If we assume that on increment of pressure to 400 kN per meter square, the degree of consolidation achieved in the sample is 40%. The time for sample A to reach the same degree of consolidation is one fourth of the time taken by sample B. Tell me when you are done.
I'm done, sir.
Okay. Just a moment. The moment I'm switching to PowerPoint presentation, the recording is not showing anything from my side. I'll just stop presenting and start presenting once more. Just a moment. Entire screen. Okay. What is happening? Okay, let's see. Next question. This is here. This is over. In consolidation testing, curve fitting method is used to determine the options are compression index, swelling index, coefficient of consolidation, or time factor. I repeat the question once. In consolidation testing, curve fitting method is used to determine compression index, swelling index, coefficient of consolidation, or time factor. Okay. Next question. Which of the following soils will generally have maximum compressibility? Which soil will have the maximum compressibility? Sands, clays, gravels, or silts? Which of the following soils will generally have maximum compressibility? Sands, clays, gravels, or silts? This question. If the coefficient of permeability is doubled and the coefficient of volume compressibility is half, the coefficient of consolidation increases by 2 times, decreases by 2 times, increases by 4 times, decreases by 4 times. if the coefficient of permeability is doubled and the coefficient of volume compressibility is halved, the coefficient of consolidation increases by 2 times, decreases by 2 times, increases by 4 times, decreases by 4 times. Okay. Next question. During consolidation, as water escapes out, both neutral and effective pressures reduce, both neutral and effective pressures increase, neutral pressure reduces and effective pressure increases, neutral pressure increases and effective pressure reduces. I hope you know what neutral pressure is. Hello? What is neutral pressure? What is neutral pressure, anyone? Hello?
Sir, core water pressure.
Yeah. During consolidation, as water escapes out, both neutral and effective pressures reduce. Uh, Both neutral and effective pressures increase. Neutral pressure reduces and effective pressure increases. Neutral pressure increases and effective pressure reduces. Okay. Next question. Curves indicating the distribution of excess hydrostatic pressures are called. Curves indicating the distribution of excess hydrostatic pressure are called isobars, isochrones, isoheights, or none of these. Curves indicating the distribution of excess hydrostatic pressure are called isobars, isochrones, isoheights, or none of these. Next question. Time factor is a non-dimensional parameter, a function of the degree of consolidation, directly proportional to the permeability of soil, all of the above. Time factor is a non-dimensional parameter, a function of the degree of consolidation, directly proportional to the permeability of soil, or all of the above. Next question. Consolidation time of a soil sample increases with an increase in permeability, increases with a decrease in compressibility, increases with a decrease in unit weight of water, increases with a decrease in permeability. Consolidation time of a soil sample increases with increase in permeability, increases with decrease in compressibility, increases with decrease in unit weight of water, increases with decrease in permeability. Next question. Two identical clay samples of same sizes, designated A and B, are subjected to consolidation tests under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation in sample B. The question is visible clearly, right? Hello? The question is clearly visible?
Yes,
Yes.
sir.
Yeah. Two identical clay samples of same sizes designated as A and B are subjected to consolidation tests under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation in sample B. Done?
Yes.
Okay. Last question. This is a fully saturated clay specimen is subjected to a pressure of 200 kilonewton per meter square in the consolidation test. Determine the degree of consolidation after a period of time when the average pore pressure is 60 kilonewton per meter square. A fully saturated clay specimen is subjected to a pressure of 200 kilonewton per meter square in the consolidation test. Determine the degree of consolidation after a period of time when the average pore pressure is 60 kilonewton per meter square. Tell me when you are finished. I'll just repeat the first two questions. For I think Shakir is there, right? Yeah.
Yes, sir.
First two questions you have missed, right? Just repeat them
Yes,
at
sir.
the end. Yeah. First, tell me when you're done with this. Okay. Shakir, you are finished? I'll just repeat the first two questions now.
Yes, sir.
Yeah. The first question was this: in partially saturated soils, the initial consolidation is due to squeezing out of water from the voids, expulsion and compression of air in the voids, expulsion of highly viscous water, or none of these. And the second question was consolidation of soils is due to load which is static and short term, dynamic and short term, static and long term, dynamic and long term. What is the type of load which results in consolidation of soils? Whether it is static and short term, dynamic and short term, static and long term, dynamic and long term. Okay, done. Hello,
Yes, sir.
Shakir, have you copied the questions?
Yes, sir.
Yeah, okay. Okay, so you start solving the questions. I'll give you 15 minutes. It's already 5:46. We'll start around 6:62. Okay, like that. Will it
Yes,
be
sir.
okay? 15 minutes time.
Yes, sir.
Okay. Start writing the answers. I hope you have completed the questions. Hello.
Yes, sir.
Are you done with the questions?
Yes, sir.
Can we start discussing the answers?
Yes, sir.
The PPT is visible, right?
Yes, sir.
Start discussing the answers now. Okay. The first question. In partially saturated soils, the initial consolidation is due to. What is the answer? What is the answer? Shakir? Hamza? Am I audible?
Expulsion and compression of air in the void.
Yeah. The initial consolidation is due to expulsion and compression of air in the voids. Yes. So there are how many stages of consolidation?
Two, primary and secondary.
Then what is initial consolidation? What happens in primary consolidation? What happens in secondary consolidation? And what happens in initial consolidation? Initial consolidation is nothing. It is the starting of the consolidation process when before the water gets expelled out, the soil is partially saturated. It will have air voids, right? So on the
Yes, sir.
application of loads, first the air is expelled out and then the water. If the soil was fully saturated, then initial consolidation would have been overlapped with the primary consolidation. Okay, squeezing out of water from the voids. Okay, clear?
Sir, what is the difference between initial consolidation and primary?
Initial consolidation is only different in case of partially saturated soil because in partially saturated soil there are air voids in the soil particles due to which during initial consolidation the air void is first expelled out. Okay, and then primary consolidation water gets expelled out. But in case of soils which are completely saturated, fully saturated, okay, then when we apply load, there will be no air to expel out, right? There will be no air to expel out. There will be only water. So in that case, initial consolidation and primary consolidation is same thing. Is it clear? Hello.
Yes, sir.
Any doubt you can tell me.
No, no, sir. Got
Yeah.
it, sir.
So in case of partially saturated soil, initial consolidation is due to expulsion and compression of air in the voids. Okay. Next question. Consolidation of soil is due to load which is what is the answer?
Stat- Static and long term.
Static and long term. And if it is static and short term, then what will happen?
Compression, sir.
Yes, very good. So the load has to be static. That is, it will not change, and it will be there for a long term. It will be there for an ample amount of time to let the water squeeze out of the soil mass. Then only it will be termed as consolidation. So consolidation is due to static and long term load. Secondary consolidation is mainly due to is the answer? Hello.
Both of the above.
Yes, secondary consolidation is mainly due to expulsion of highly viscous water, and when the water is expelled out, then there is a plastic readjustment of the soil particle, in the soil mass. Plastic means they are changing permanently. Okay, and on the removal of load, they will not revert back to their original position. So it is a plastic readjustment. So after the initial or primary consolidation, when the water is expelled out, then the highly viscous water between the soil particles, it is removed during the secondary consolidation, and upon the removal of that, there is a permanent plastic deformation of the soil particles due to readjustment. So it is both of the above. Next question. Time is an important factor in the consolidation of clays because of low value community. True or false?
True.
Yes, it is true, because clay has low value of K, because of which the time, what will happen in the time?
The time for consolidation will increase.
Yes, so the time, as the time increases, it becomes a vital factor in determining the consolidation effect. Okay, so it is true. Okay, next question. Which of the following is not an assumption in Tansagi's theory of condemnation and consolidation? What is the answer?
The drainage of water occurs in both
Yes,
horizontal and
very
vertical
good.
directions.
Because soil mass is homogeneous and isotropic, it has to be, because they are considering one-dimensional consolidation. Soil has to be homogeneous and isotropic. Soil is fully saturated, yes, because they are not considering the effect of air voids. Only in exceptional cases. Darcy's law is valid, yes, Q equals to KIA. Only thing is, drainage of water occurs in both horizontal. Drainage of water occurs where? In the direction of,
Application of force or
yes,
load.
in the direction in which the load is applied, in that direction only the drainage of water it occurs. Okay, so it is not in both horizontal and vertical direction. No lateral expulsion of water will occur. Okay, we are applying load in the y-axis. Water will not expel in the x-axis. It will be in the y-axis only. So yes, this is the right answer. Coefficient of consolidation depends on.
Sir, all of these.
What is the formula of coefficient of consolidation?
And that CV is equal to K divided by MV into gamma W.
What is K?
Coefficient of permeability.
What is MP?
Coefficient of volume change.
And gamma W is the unit temperature of water. So it is
Water.
it is basically a function of all these three. Okay,
Yes,
so it
sir.
is all of these. Okay, good. Now this question. Have you solved this?
Sir, I got 385 days.
Yes, it will be 385 to 386 days. How do you solve this?
385 days
And
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 19 hours. Sir.
and the second one, and the second part,
Uh,
what did you get?
oh, sir, I forgot that.
You forgot that.
Hmm.
Okay, I'll solve it. So it has said 50% of consolidation in both the cases, right? So if we consider same degree of consolidation u, then for that time factor will also same, right?
Yes, sir.
So time of consolidation will be directly proportional to what? D square by Cv, right?
D square by CV. Yes, sir.
Yes, D square by Cv. Now it is the same soil, so Cv will be same. A will be proportional to what? B square only.
D square only.
A square. Yes. So if we consider the time for what is it, T2 as field. Okay, T2 is the field. So consolidation in the time taken for consolidation in the field divided by time taken for consolidation in the lab, like this. Okay, what is the formula for this? Depth of the soil sample in the field by depth of sample in the lab, right?
Yes, sir.
Whole square. Now, what is the df in the field if we consider double drainage? Df is what? 4 meter divided by 2. That is 2 meter. That is 200 centimeter, right?
Yes, sir.
Yes. So I can say over here, EF time taken in the field which you are required to calculate will be equal to time taken in the laboratory, that is equals to how much? That is equals to 20 minutes, right?
Yes, sir.
Into EF, that is equals to 4 meter by 2, that is equals to 2 meter equals to 200 centimeter divided by depth of the cell sample in the laboratory. And this will be whole square. So what will we get? T, it is 20 minutes, it is 200, it is how much? 24 mm, and it is also double drainage, so it will be 12 mm, that is 1.2 centimeter. So 200 by 1.2 whole square into 20. You will get approximately 386 days, right?
Yes, sir. Sir, for second one, what is the answer? Second
For
case.
second one, you do it. Placed atom. Placed atom means placed atom in the field. It has only single drainage. Same
So
thing.
I got 1540 days.
1544 it will be 1544. It says same thing if you take df, that is TL equals to 20, DL equals to 1.2, because in the lab it is it was allowed double drainage, right? But
Yes, sir.
DF will change. DF will be how much? Say for single drainage in the field it will be 4 meter or 400 centimeter. So just put 400 by 1.2 whole square into TL, that is 20. I believe you will get for the second part you will get EF equals to, it's okay, it's, 1540 will also be counted as the right answer in competitive examination, no options are there, but it will be something around 1543 to 1544. Okay, clear?
Yes, sir.
Any doubt regarding this sum?
No, sir.
Okay, Amrita, can you hello Amrita, can you follow? Okay, just a minute. Next question, have you solved this?
No, sir.
Not solved this. What is the formula for the height of solids?
I have not know that.
I have given the area of sample, right? Yes. Dry weight of sample divided by G gamma W into A. How are you getting this? A into H is equals to volume. Weight by volume gives us the unit weight. Unit weight by unit weight of water gives us the G. So height of solid is equals to dry weight by G gamma W into A. You put everything in this formula and tell me what you are getting. Weight of the dry sample is 190.24. G is how much? 2.67. Gamma W will be taken as 1 because it is gram per cc CGS unit, scale of unit, and A will be equal to 50 cm square. Tell me what you are getting.
Sir, 1.425 meter.
1.425. Very good. 1.425 centimeter, right? Isn't it?
Yes, sir.
Yes. What is the initial height? Initial height was
25 mm.
that is 2.5 centimeter.
Yes, sir.
Now what is the void ratio? Volume of voids by volume of soil solids, right? Right?
Yes, sir.
Volume means area of cross section into height. So for the same area of cross section, it will be height of the voids occupied in the soil mass divided by height of the soil solids, isn't it?
Repeat, sir.
See, what is void ratio? Void ratio is volume of the voids divided by volume of the soil solids, right?
Yes, sir.
What is volume? Volume is area into height.
Yes, sir.
Area into height. So if the area is constant, then you can cancel out area in the numerator and denominator. Then what can we say? Void ratio is the height of the voids divided by height of soil solids, isn't it?
Yes, sir. Area will cancel.
Yes, area cancel, height of the voids and height of soil solids. So initially it was 25, then after consolidation it became HS 1.425 centimeter. Then the if the voids had been reduced, then what was the volume of void, then what was the height of void? You can find out using H0 minus HS. So H0 minus HS will give you the height of the voids in the sample, and divide by the height of the soil solids, you will get the void ratio. Now tell me the answer. H0 minus HS divided by HS.
The 0.754.
Okay, yes, 0.754. Clear?
Yes, sir.
So using height, change in height, you can find out the void ratio of a soil sample subjected to a consolidation test. Okay.
Yes, sir.
Next question. Undisturbed sample of clay stratum 2 meter thick tested in laboratory. Have you solved this?
No, sir.
Why not? You have not solved any question today. How to solve this? Tell me. I have written over here half the ultimate settlement. Right?
Yes, sir.
So if the settlement is half, then what is the degree of consolidation? In percentage?
Okay. 50%.
Yes. U. Degree of consolidation is how much? It is 50%. Now when U is less than 60%, what is the formula for TV?
PV into T 50% square divided by D square. Then it's here.
TV, time
Okay.
factor. Pi by 4
Okay.
into
T 5 by 4
U by
U
100.
percent square whole square.
Yes. Okay. So you find out TV in this formula, and you have to calculate the time taken, right? So time taken will be how much? The formula is CBT by D square. So TV d square by CB, isn't it? Isn't it?
Yes, sir.
Yes. So you put TV from there here over here. D will be how much? What is the value of D for double drainage? Stratum is 2 meter thick,
1 meter.
1 meter or 100 centimeter. Okay, because CV is in cm square per second. Okay, so you have to find out. You have to put D in centimeters, and then you'll find out you will get the value of time in seconds. You convert the time in seconds to time in days. Okay, do it and tell me the answer. Have you solved it?
Sir, 113 days and 14 hours.
That is, you will take it as 114 days. Okay, upper hand you will take always.
Okay.
114 days, right? What is the value of time factor you have got?
Yes, sir. 0.1963.
0.1963, 0.197. Yes. So it is clear how to solve this. You have to
Yes, sir.
look carefully in the question. I
I
have
got
told,
confusion here, sir. So I can half of ultimate settlement. I was
yes,
not getting
half
this
the
particular.
ultimate settlement. That means 50% degree of consolidation. That is a clue.
Yes,
Okay.
yes,
I could have written like this, like assuming double drainage, how long will it take to attain 50% degree of consolidation? Then you could have easily solved it, right?
yes, yes,
Yes, but half settlement means this only. Clear?
yes, sir.
Yes. This question, could you solve it? Hello?
No, sir.
How many questions could you solve today?
Sir, sir, out in numericals only two numericals and other all three questions.
There were six numericals, right?
Five, sir.
Five numericals.
Yes,
One,
sir.
two,
Question number
three, four,
7, 8, 9.
five, six. Six numericals.
Sir, only two I did.
Okay, it's okay, no problem. So tell me, how can I solve this? There are two clay specimens A and B. They have thickness 2 centimeter and 3 centimeter. Okay. Let's discuss this question. This is a long solution. And they have equilibrium void ratio. That is the void ratio, initial void ratio. It is 0.68, 0.72 under the pressure of 200. Right? Okay.
Yes, sir.
Now the pressure has been increased. Okay. So this pressure, how can you term the increment in pressure in numerical form? Del sigma, isn't it?
Yes, sir.
Yes. So del sigma will be how much over here? 200. It was initially 200, changed to 400. That
400
is
minus 200. It will come to
200.
200.
Yes. And after the increment of pressure, the void ratio of the two specimen changes from 0.68 to 0.5 and 0.72 to 0.62. Find the ratio of the coefficients of permeability. Now, to find out the ratio, find out K. What is the formula for K? What is the formula for K? K
K is
equals
equal to
to
CV MV into
CV
gamma W.
MV gamma W. Okay.
Yes, sir.
Now you are told to find out the what? Yes, the ratio. Okay. Now the two clay specimens, they will have, they can have different coefficient of volume change and different coefficient of consolidation, but gamma will be same. Okay.
Yes,
So
sir.
first you need to focus on this parameter and this parameter, isn't it? So what is the
Yes, sir.
formula for MV?
K divided by CV into gamma W.
What? No, no, no. What is the formula? Generalized formula for MV.
So that change in volume divided by original volume into 1 divided by change in pressure or pressure.
Yes, change in volume you can express it in terms of void ratio, right? Daily by 1 plus E0
1 plus E naught
into
into 1
1
by
by
del
del
sigma.
del sigma. So for this you have to find out MVA and MVB. For A, the change in void ratio will be how much? 0.5 0.5 minus 0.68, right? Final minus initial. Clear?
Yes, sir. Yes, sir.
And for B, it will be 0.62 minus 0.72. Final minus initial. Okay. For A, E0 will be how much?
Sir, initial
0.6.
minus final because pressure is increasing. Means then void ratio will decrease. It
Void
should be
ratio is decreasing, pressure is
it should,
increasing. But del sigma will
so
be positive, right? Because pressure is increasing.
yes, sir. Then it should be initial minus final. It should come positive.
Don't consider this minus n first. Change in the value of something means final minus initial. How it has changed? It has decreased, so the value is negative. It has
Yes,
increased, the
sir.
value is
It will come
positive.
negative, and again here negative is there. It will come positive totally.
Yes, so del E will be negative. Final minus initial. See, final is less, right?
Yeah, yes, sir.
So final minus initial will be negative. Here also negative. E0 for A will be 0.68, for B will be 0.72. And del sigma will remain constant for both the cases. It is 200. Isn't it? So you do it and tell me the value of MVA and MVB. What are the values of MVA and MVB? Tell me. And the units of your answer of this MV will be meter square per mega Newton. Okay, meter square
Meter square per kilonewton, sir.
per kilonewton. Okay, no problem. You can do it in kilonewton also. But okay, you can do it in kilonewton also because I wanted the answer decimal form. Okay, okay, kilonewton is okay.
5.3, 5.35 into 10 to power minus 4 meters square per kilonewton.
Just a moment.
For A.
5.36.
3, yeah, 3, 5 or 3, 6.
5.3 5.36 into 10 to the power minus 4. Okay,
Yes, sir.
10 to the power minus 4 I want to write it removing the exponents and in decimal form, 10 to the power minus 4, that is meter square per kilonewton, right? Okay, write it like this only. Anyway, you're going to find out the ratio. 5.36 10 to the power minus 4, right?
Yes, sir.
Meter square per kilonewton. And the second one,
2.90 into 10 to the power minus 4.
yes, 2.10 to the power minus 4 meter square per kilonewton. Okay. Now for finding the ratio of K1 by K2, you have Ka by Kb. You have to find the ratio of MVA by MVB, isn't it?
Yes, sir.
So what is the ratio of MVA by MVB?
Sir, 1.843.
1.845 I've got. Okay. 1 point. I have got 1.845. I have written it in mechanism. It's okay, no problem. 1.843. Fine. Now you have got the ratio of MVA to
By
MVB.
MUB.
Now you need the ratio of CBA to CBB. Right? How can you find out CB? CB is how it is dated. Put to time, right?
Yes, sir.
To time. Now, just a moment.
So we can find that E naught, this initial vibration minus final vibration divided by log of final my initial citrus, log of 10.
Log of 10. No, no, no. See, for the same
We have
degree
that.
of, for the same, what is the formula for time? Time equals to TB d square by CB, right?
Yes, sir.
Now for the same degree of consolidation, TB is constant. 40% degree of consolidation, TB will be constant, isn't it?
Yes, sir.
So
Yes, sir.
time will be equals
It
to
will be
proportional to d square by CB. So I can write over here EA by TB equals to what is the yes CB d square by CB, yes, dA by dB whole square, right? Divide by CB, it means CBB by CBA, isn't it?
repeat again.
What is the formula for time? Time is T time factor into d square by CB.
Yes, sir.
Formula for time is, what is the
Yes,
formula
sir.
for time? TV
TV into D square by CV
d square by CB.
into
Now
by
for the same degree of
CV.
consolidation, TV is constant. TV is constant. So
Yes, sir.
time becomes what? Directly proportional to d square by CB. So
CV
TA by TB is how much? dA by dB whole square into CB by CA,
into
no?
CB by CA whole square. Yes, sir.
dA by dB whole square, because time is directly proportional to d square, inverse proportional to CB, right?
CV.
So
Yes,
TA
sir.
is a
Yes, sir.
numerator in the numerator, CBA in the denominator, right?
Yeah, yes, sir.
So now what do you need? You need CBA by CBB, right? Just interchange. CBA by CBB will be equals to how much? dA by dB whole square into TB by TA, right? After interchanging, just interchange the sides. Clear?
Yes, sir.
Clear? This is
Yes, sir.
so now dA by dB. You have the values of dA by dB. How much? What is dA? What is the value of dA?
D, So thickness is 2 centimeters. Means it will be half of this. This
Why
double
half?
drainage.
Have I written anywhere that it is single drainage or double drainage?
No.
No. So
Okay.
whatever the value is, either it is double drainage or single drainage, it will be a ratio, right?
Okay, sir.
So 2 by
Yes,
2
sir.
and 3 by 2, 2 by 2 divided by 3 by 2 and 2 by 3, same thing, right?
Yes, sir.
Yes, that is whole square. And time, what is the time? Time required by specimen A to reach 40% is 1/4. So if time required for B is 1, if time required for B is 4, time required for A is 1. So this will be equals to 2 by 3 whole square into 4 by 1, right?
Yes, sir.
Is it clear? So find out the ratio of CBA to CBB in fraction. Tell me in fraction. It is very easy.
0.11.
0.11. Whatever I said, what is dA is 2, dB is how much? 3. Time for B is 4, time for A is 1. So how are you getting 0.11?
1.77.
What?
1.77.
1.77. Yes, basically 16 by 9. I told you in fraction. 2 square 4 into 4 16 divided by 9. Right. Okay,
Yes, sir. Yes,
1.77.
sir.
I'll write 1.78. 1.778. Now you tell me the value of Ka by Kb, the final answer. How much? It is CBA by CBB into MBA by MBB. Right. Just multiply the two values.
That's 3.276.
Yes, it will be equal to 3.28. Right. Rounding off to two decimal places.
Yes, sir.
Yes, 3.276 or 3.28. So is this clear? Any doubt you have regarding this question?
Perfect. Centimeters to care per
Yes.
second.
What?
No, no, no.
What did you say?
Correct, correct, sir.
Hello?
Nothing, sir. It is ratio, sir. No,
I cannot follow you. Did you say something?
no, no, sir. It's okay. I actually told the unit of this, but actually we don't have any unit. It's ratio.
No, ratio. How I will have a unit? Yeah.
Ye-
Okay.
Yeah, yeah.
Okay. Yes. Just a moment. Fertilizer. Okay. So this is over. Yeah. Next question. In consolidation testing, curve fitting method is used to determine what?
Quotient of consolidation.
Yes, coefficient of consolidation is the only thing we require to find out. Curve fitting method. Yes. Which soil has the maximum compressibility?
Please.
Yes, clay soil has the maximum compressibility. Next question. Coefficient of permeability is doubled and coefficient of volume compressibility is half. The coefficient of consolidation will be how much? What is the answer?
I've been
You didn't do this.
actually I actually forgot this one.
You
This
forgot this.
question.
What is the
This question.
what is the formula for coefficient consolidation? CV.
Increase by 4 times.
Yes, increase by 4 times. Yes, CV equals to K by
K divided by
MV
MV gamma W.
MV gamma W. So
W.
this is doubled. K is doubled. That is into 2. And
2K.
MV is half. That is by 2. So 2 into
MV
2,
by
4.
2.
It is becoming 4 times
Yes,
the
yes.
initial value. So increase by 4
Initial.
times. Good. Okay, clear? Shakir.
Yes, yes. Yes, yes.
Yes. This is a very important formula actually. Okay. During consolidation, as water escapes out, what happens? What happens as the water escapes out?
The neutral pressure reduces and effective pressure increases.
Yes, because the water escapes out, so port pressure will reduce, and if the port pressure, as the port pressure reduces, to the increment in the pressure load, the effective pressure is a grain transfer of load. It enhances, the effective pressure increases. Good. Next question. Curves indicating distribution of excess hydrostatic pressure. What are these curves called?
Well, I saw it.
Iso heights,
Yes, yes.
isochrones it will be. Hydrostatic pressure. Iso heights is different thing. Google it up. You will find it in any hydrology book, I believe. I'm sure. Isobars is excess. Isobars is equal pressure and excess hydrostatic pressure. The distribution is given by isochrones. Okay.
Yes, yes.
Okay. Time factor is
Non-dimensional parameter.
this is the answer.
A function of degree of consolidation.
Non-
Think CV equals to
Yeah, second part is a function of degree of consolidation. If it is coefficient of consolidation, then it is correct.
just a moment.
This degree.
Just a moment. First part it is clear, it is a non-dimensional parameter, time factor. Second part it is a function of degree of consolidation. Isn't it? It is a function of degree of consolidation.
Sir, degree of consolidation we are showing as U and CV is coefficient of consolidation.
Okay, sorry. Degree of consolidation is that formula. Yeah, yeah. This coefficient of consolidation, degree of consolidation. Yeah, because time factor. What is the formula for degree of consolidation and time factor?
U, we are writing that U is equal
If it is less than
function of U.
60, if it
Yeah.
is less than 60, pi by 4, u by 100 whole square. If it is more than 60, 1.7813 minus 0.9322 log to the base 10. Then
Yes, sir.
what? 100 minus u, right?
Yes, sir.
100 minus u. So TB is a function of u, degree of consolidation. TB is a distribution parameter. Now TB equal to CB T by D square, and CB equals to K by MB gamma W. So TB, if it is directly proportional to CB, then TB is also directly proportional to K, right?
Yes, sir.
Because if you put K by MB gamma W over here, TB equals to K into T by MB gamma W into D square, right? So all the three are correct, isn't it?
Yes, sir.
Is it clear?
Yeah, yes, sir.
Yes, so it is non-dimensional parameter, function of degree of consolidation and attribution to the permeability of soil. Okay. Yeah, I got confused with the degree of consolidation and the coefficient of consolidation. Degree of consolidation is this function, this formula, where it has two different kind of formulas for two different kinds of degree of consolidation, less than 60 or more than 60, isn't it?
Yes, sir.
Yes, it is all of the above. Okay. Now, next question. Consolidation time of a soil sample
Sir, increases with decrease in impermeability.
increases with decrease in permeability. Yes. And how to determine that? Time equals to, what is the formula? TB d
Into
square
d square by cv.
CV. CV equals to what? If you don't write CV, what can you write?
1.
K by
100%.
MV
Okay.
gamma W.
A by mv into gamma w.
So K is basically in the denominator. MV gamma W, it goes to the numerator. So T will be equals to TV d square MV gamma W divided by K. So compressibility, it is T is directly proportional. I just write it for directly proportional to the coefficient of compressibility.
As a what equation?
T is directly proportional to the unit weight of water, but T is inversely proportional to the coefficient of permeability, isn't it? So with decrease in compressibility, T will decrease. Decrease in unit weight, T will decrease. But decrease in K, T will increase. Right? Hello?
Yes, yes, sir.
Clear?
Yes, sir.
Yeah. So it will be increases with a decrease in permeability. You are right. Good. Okay. Next question. Could you solve this?
Sir, I tried, but this is only showing single drainage and double drainage. But it is not given how much is that.
It is not given. You don't have to find. See.
I think we should use that ratio formula.
Yes, yes, yes. Suppose dA. What is dA? Have you have said
Drainage.
drainage takes place to one phase in sample A. So dA, let dA be equals to H, and both phases in sample B, two identical clay samples, right? So dB equals to
Okay.
what?
H
H
by
by
2.
2.
Yes, sir.
H by 2.
सर
Okay.
4 times कम हो जाएगा टाइम
4
रिक्वायर्ड.
times कम हो जाएगा, right? So TA by TB equals to how much? dA by dB whole square. That will be equals to dA by dB, it will be equals to 4. So you have to find out what? Find out TB, right? TB equals to TA by 4. TA by 4. What is TA? 10. 10 by 4 is how much? 2.5 minutes. Okay, clear?
Yes, sir.
So even if it is not given, the height, this sums time, the relationship of time with MV, CV, D. If you take the ratio, if there is if there is a sum with two samples given, you have to compare, find out the ratio. Then there is no need of taking the like what to say, comparing the exact height. You don't need to take. Just the relationship is okay. Ratio is okay. All right.
Yes, sir.
Next question. Could you solve this?
No, sir.
Okay. So, how will you solve it? Do you have any idea? See, it is said fully saturated, right? Initially, it was fully
Yes, sir.
saturated. So when we start applying the pressure, at a certain point of time, the pore pressure was 60. Okay. So you have to find out the degree of consolidation. So if the degree of consolidation is 100%, that is the end of consolidation. Okay.
Yes, sir.
What will the pore pressure be?
0.
0. Very good. So at that point of time, when we are going to find out the degree of consolidation, the pressure was 200. Ignore the units. The pore pressure was 60. The effective pressure will be how much? What is the effective
140.
pressure? 140.
140.
Yes. Now, this effective pressure is not the full, what to say, full consolidation process, right? When you find out the degree of consolidation, what do? You find out the what to say, uh, change. If find out the settlement at a particular point of time to the ultimate settlement, right? But since here I'm not giving you any problem on settlement, you have to consider the stress. Okay, while a particular point of settlement has been occurred, you have to keep in mind that there are two forces at play. One is the total stress, one is the pore pressure. So if there is pore pressure, okay, the effective stress is 200 minus 60, 140, and this will cause a certain amount of settlement. Okay, now at the end of consolidation, again, since we are keeping the pressure to 200 only, sigma will be equals to how much? 200. What is the U at the end of consolidation? UF
0.
0. So what is effective pressure final?
Same. 200.
200. So won't this ratio give me the degree of consolidation?
Yes, sir.
Yes, because this stress, it decides the degree of settlement, and degree of settlement is also decided by the degree of consolidation. So we can write down the degree of consolidation equals to sigma dash divided by
70%.
sigma dash f
Sigma final.
into 100%. That will be giving us how much? 70%. Clear?
Yes,
Clear,
sir.
sir.
Yes. So by taking the ratio of effective stress at a particular time to the final effective stress upon the end of consolidation, you can find out the degree of consolidation. Right?
Yes, sir.
Okay. So any doubt anywhere?
No, sir.
No, sir.
Okay. So this was the mm, second last class, I believe. I have one more class left with you, isn't it?
Yes,
You have
sir.
12 classes with me, right? 12 live
Week,
sessions.
week 12.
Yes, week 12 we have settlement of soils, compressible soil layers. In that in that session I'll be giving you sums on consolidation and settlement due to consolidation. Okay?
Sir?
Yes.
Okay, sir.
Sir, next Saturday, I think it is Eid, sir. Do we have class on that day or not?
Yes, this Saturday we will be having class because I have to complete the class by next Saturday.
Okay, sir.
Okay, if you can't attend the class, there is no worries. You will be getting the because this is a scheduled live session, no? So I cannot
Yeah,
skip. I cannot skip. Sorry for that. But you will be getting the PPT and the recorded live session also. No worries. Okay. I know if it is a one-to-one discussion, one-to-one interaction in the live session, it is always better to understand the
yes, sir.
concepts. But still, it will be of help. And since you have learned the basic concepts of consolidation here only, that is settlement of compressible layers is a part of the consolidation process. Okay, so the major concepts of consolidation I have already discussed over here. Okay, MV, CV, TVT, everything I've discussed. Only rho, that
Yes,
is
sir.
the settlement part, is left. There are two formulas related to settlement and degree of consolidation with settlement, finding out the settlement using height and K and all those formulas. So basically, same sum, just a bit uh, here
Yes,
and
sir.
there I'll be doing over there. So no worries about that. And if you follow some standard textbooks, you'll be okay with the concepts. Okay. So all
Yes, sir.
right then. Thank you for attending the class. It's a good
Thank you, sir.
interactive live session. Thank you so much. Have a good
Thank you so
evening.
much.
Bye bye.